And not this class, like
Well,
he still doesn't.
the thing about like McIntyre because of that, because he made homework so many times. Like
Okay, they ready? Ready, okay, alright, so here we go. Polynomial functions is section 2. Well, guys, you've been doing polynomial functions forever. Here's a polynomial function. X to the first, known as what?
linear.
Linear, okay. Here's another one, 2x squared plus 2. Quadratic. You have been doing polynomials forever. One more. 2x cubed plus 2. Cubic. If I did another one, x to the fourth, it's what? Quartic. If I do another one, x to the fifth. Quintic. Okay, there's names for all of them. After quintic, I forget them all. So I just don't even worry about it. But you have been doing polynomial functions forever, so this is not a big surprise. Okay, let me go here, here, here. Okay, here. Okay, this slide is all about a polynomial function. If you graph it, it's really what? Smooth. Okay, for example, isn't a parabola nice and smooth? Isn't it continuous? Doesn't it keep, I mean, you can get to the next point, the next point, the next point. I mean, you want points, you can get points. So what's not a polynomial? This is a polynomial. What's not? How about this?
That's what I was going to say, absolute value.
How about the absolute value function? Is that smooth?
No.
No, that's actually sharp. Like, don't touch that. That's not a polynomial. Okay, what about this one? Do you remember what those are called? Those are called piecewise. Yes or no? Is it a polynomial? Why not? It's not continuous for one thing, and it is not. It's not smooth. Okay. So basically, this is a polynomial. This is not a polynomial. So when you graph them today, you will not get this. You'll get something like this. That's a parabola or a quadratic. You could also get something like this. Okay, that would be probably an x cubed function. Okay, and this would be an x squared function. Good. Yes. Okay, keep moving. Okay, a little exercise with your graphing calculator. It says using your graphing calculator, graph the function y equals x squared, x to the fourth, x to the sixth in a standard window, which means 10, 10, 10, 10. Okay, I'll catch up with you. You need one? They're right there. Okay, x. Mine are in, you know it says standard window, but can I change the window on it? Can I go up, watch this, right 2, left 2, up 2, down 2, 2, 2, 2, 2, 2, okay? So go to your window, change it to 2s. It will look better, I promise. Okay, 2 left, 2 right, 2 down, 2 up, I got it. Hit the graph button, watch this. This is what you're supposed to get out of this. Here comes x squared. It's in blue. Here comes x to the fourth. It's in red. X to the sixth. In black. Do they all kind of look the same? Yeah. Don't they all look like parabolas? Yeah. Right? Okay. So that's what you're supposed to get out of it. But one more thing. The blue is x squared, the red is x to the fourth, the black is x to the sixth. What do you notice about that vertex 0, 0? When it hits 0, 0, What about when the power gets bigger and bigger and bigger? What does the graph look like at 0, 0? As the power gets bigger, bigger, bigger. Doesn't it? What? Flat. It's flat. You guys, the bigger the power, the flatter the graph gets, right at the x-intercept, which is 0, 0. So guys, if I did this, if I went x to the 8th, what would you expect it to do? Even what? Even flatter. It should be. Here it comes. See? That's x to the 8th. It's even flatter. But guys, look what happens right here. See that point? See that point? They're all hitting that same point. What is that point? 1, 1. They all hit that point. 1, 1. And they all hit this point 0, 0. But the bigger the power, the flatter it is. So you guys, on your paper, you should probably do something like this. 1, -1, and 1. Here, here, here. And this is kind of what it does for x squared. And then you should say, well, it does this. For what? Whoa, I messed up. Sorry. For x to the what? 4th, right? And then what's it do for x to the 6th? Flatter yet, right? Okay? So what you're supposed to get out of this is two things. The higher the power, as the power increases, comma, what? As the power goes up and up, 2, 4, 6, 8. Nobody is talking. The graph. The graph what?
Goes flatter.
Flattens out. Gets flatter, yeah. Flattens out near the vertex 0, 0. You can word that in any way you want, as long as you understand it just gets flatter and flatter right at the x-intercept 0, 0. You okay? Yeah. Okay. Now, this is the same slide, except instead of x to the 2nd, 4th, 6th, it's what?
The negative.
It's what?
The negative.
No, not negatives.
The odds.
Odds. So now I'm asking you to check the odd powers. Okay, so punch it in, see what happens.
They do the same thing.
Well, you're going to see it's not quite the same. X to the what? 3rd? X to the 5th? X to the 7th? Okay, and I'm going to graph it on that same window, 2, 2, 2. There's an x cubed function. There's an x to the 5th function. There's an x to the 7th function. So what's happening? What? Flattens out. Right at what point?
0, 0.
But 0, 0 is called the x-intercept. So right at the x-intercept, guess what happens? The bigger the power, the flatter the graph. Do you get what I'm saying? So it's kind of the same thing as the last one. But did you guys notice? Odd functions do what?
You get skinnier.
Well, no, but on the left they go what? Down. On the right they go up. Did you notice on even powers? On the left it goes up. On the right it goes up. Okay, could I make them go down, down?
Yeah.
How do I make an even power go down, down?
Negative.
Make it negative. Yeah. Okay, you're getting there. We're getting there, guys. Okay, let's go back here. Probably just a quick graph. Oh, I didn't say this, but did you notice?
Yeah.
Did you notice that this 1, 1 is always the same, and so is -1, -1? Okay, so here is x cubed. Here is what? X to the fifth. Here is x to the what? Seventh. So basically you could say that about the same thing as the power what? Increases, comma, the graph, what? Flattens out. Can I just say at the x-intercept, which is known as 0, 0. Good? Do you get it?
Yeah.
Yes. So what would be even more flatter than x to the 7th? X to the 9th, 11th, 13th. Okay, this is a transformation problem. You've been doing these since the middle of chapter 1. Ready? It is, what's the parent?
Prime.
What's the parent?
Prime.
X to the what? Fourth.
Not quadratic. No. Yeah.
Quartic.
That's a parent.
Did it?
Okay, go. Should take you half a minute. Well, I'm thinking you know that x to the 4th looks just like x squared, don't you?
Yeah.
Except it's a little flatter at the vertex. Okay, the vertex is always 0, 0, right? 0 goes in, 0 comes out, right? Okay, where's yours going? Right 3, then what? What's that? Down 5, okay, down 5. Okay, pretty easy. Here I go. Right 3, 1, 2, 3. Down 5, 1, 2, 3, 4, 5. Somewhere in this area. Got it? Okay, you know it's x to the 4th, so you know the vertex is a little bit flatter. Okay, not a big deal. But do you know this? This parent that you're talking about does not quite act like an x squared. 0 goes in, 0 comes out. What does 1 do? Put 1 in.
Comes out.
1 comes out. Put a 2 in. 2 goes in, 16 comes out. So you guys, the parent on this one goes a lot faster up. So when you do this, you say, oh, it acts just like the parent because of the number 1. So I go over 1, up 1. Back up 1, up 1. So right now, this is what I have. Flat. Kind of flat on the bottom. But where's the next point? Acts like the parent. 2 to the right, what? 16 up. You're down 5. So you'll be at 11. You'll be at 5, 11. So here you go. Couldn't you just mirror it over? What am I mirroring it over? The line of symmetry, right? So 5, 11 mirrored over becomes what? 1, 11? So here's the other half. Good? It's very narrow, right? X to the 4th takes off like lightning. X to the 6th, that'd be lightning squared. I just good? Are you okay? Hey, all you have to do is move it over 3, down 5, flatten it out on the bottom, and just understand this point and this point are on the graph somewhere, right? Okay, leading coefficient test. On your calculator graph, this, and this is an x to the what? Fourth. It's a fourth degree polynomial. I want you to graph it on your calculator. And how similar is it to this one right here? Which we already know it's that. This is x to the fourth. What does this look like? I'm not going to do it. I'm going to wait for you. Show me when you get it. I just want to see it. Show me a picture so I can go back up there. You got it? Oh, zoom out. I'm sorry. Your window is too small, guys. You got to go back to standard window, I guess. Okay. Okay, Sydney's got hers done. Here's what she had. I'm looking at hers. It's a 10 by 10 window. She's got this. Something like that, that, and that. Okay. Okay. So, what's similar? Hey guys, you notice this? Up, 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 right? So, how are they similar? Well, they both, let's just say this, the graph, I'll just say it this way, the graph rises where? On both sides. Okay? Both, I'm going to say both ends. Okay? Period. You're also supposed to be saying this. They're both what? They're both even, aren't they? They're both even functions. Okay. So even functions, if they go up, up, what would x to the 6 do? Up. X to the 10th.
Up.
How would it go down?
Negative.
It's got to be negative. Yeah, if this would have been negative x to the 4th, it would go down. So the leading coefficient is telling us quite a bit. So watch, you have to do this for me, will you? Will you give me something that goes down on the left and down on the right? What would be a function? What kind of function would do this? Negative, okay, good. X to the what? Even, just say even, okay, 2. Or could you say this? This? Yeah. As long as you say negative, even, down, down. Even functions act like parabolas, down, down, up. Up, up, down, down. Okay? That makes sense? Okay. I was just talking about end behavior. Now we're talking about it for sure. Interpret the meaning behind this statement. Listen to this. If a function's highest power is what? Even. Like for instance, this. X to the 4th. And the leading coefficient is what? Positive. Leading coefficient is positive. Like 2. X to the 4th. Then this is true. But how do you read that? Go ahead, Emma. Okay, as x approaches the arrow is as x approaches negative infinity or positive infinity. Watch this. This is what it means. Here's negative infinity for x. Here's positive infinity for x. So as you put numbers into negative infinity, what does your function do? It goes where? Yeah, but that's what? Up. Up on the left. If you start putting numbers in for your x's to positive infinity, it goes what? Positive infinity is up. So up, up. What that says is up, up. Yeah? As you put your x's in to negative infinity, it goes up. To positive infinity, it goes up. And that's how you read it. I always say your y values. Don't say f of x. Say your y values will do what? Go up. Okay. Why am I telling you this? Because this is how pre-calc talks, and this is how calculus talks. They don't say up, down, up, down. They don't do that. They say, as your x's approaches negative infinity, your y's go up forever. As your x's approach positive infinity, your y's go up forever. Yeah? Okay, guess what? This morning, I put this in, and you don't, oh, wait, I didn't see this. This is brand new also. What if the leading coefficient is now not 2x to the fourth, but negative 2x to the fourth? As x approaches negative infinity or what? Positive infinity, then your function, your y values will approach what? Negative infinity. Down, right? This would mean down on the left, down on the right. Here's another one. Now this is the one that's not in your slide. So tell me, if the highest power of x is odd, like x to the fifth, and the leading coefficient is what? Positive, 3x to the fifth. Then does this make any sense? As x approaches what? Okay, here's negative infinity. What does your graph do? It approaches negative infinity. It goes down. And as x approaches positive infinity, what's your graph do? What do your y values do? They go up. Isn't that what odd functions do? Yeah. And then what do they do in between? They do whatever they want to do, right? We don't know yet. Okay. They can go crazy on you. This is just end behavior. Okay, what about this one? What if your leading coefficient is negative? So negative 5x to the 7th. What's going to happen on this one? It's reflected over the x-axis, isn't it? So that one would do what? Up on the left, down on the right. How would you word that? As x approaches negative infinity, all your y values approach what? Positive. Whoa, that's bad. Positive infinity. As x approaches positive infinity, right here, what happens to your graph? Negative. Your graph goes down forever. Good? All right. This is not how Algebra 2 talked. That's why this is new to you. Are you okay with what was presented? Okay, if not, you got to talk to me. Can't do it tonight, sorry. Okay. This is not, there's no slide. Just answer these questions. Ready? Even functions act like what? Did you know that?
Yes.
Okay. 2, 4, 6, 8. Okay. If it's positive, it's going to be on the left, up, right, up. If your leading coefficient is negative, what? Down, down. Odd functions act like what? Lines. And what I mean by that is, lines, they go like this, down, up, or up, down. Okay. Odd functions. If your leading coefficient is positive, what line is it? Which one is it? Left arm up, right arm down. Positive slope. What's positive slope look like? This way. What's negative slope look like? Downhill. Okay? So positive would be what? Down on the left, up on the right. Don't know what it does. This one would be what? Up on the left, down on the right. Good? That's just a quick comment on what happens. Okay. Oh, 3 minutes. I don't know which, hang on. Let me read through all that. Okay, this one, go 2 slides forward. I just want to get this one in because this one could show up on your homework. Okay? So they're asking you to find the what? Zeros of your function, which is basically saying, when is your y 0?
So it's looking for y equals 7.
Okay? So zeros are basically whenever your y is 0, right? Which means you're trying to find what? You guys, you're trying to, zeros are x-intercept. Okay, I think you can do that without my help. Go. You should try it without your calculator. So what do you think? What?
0, 0.
Okay, you got one of them, 0, 0, but that's using your head doing trial and error. 0, 0 is the answer. You're right. But there's more zeros, yes. Say again? Plus or minus 2. But how'd you get it? You factored. I think you guys should factor these polynomials. Take out the... Ah, my fault. Anyways, you should get here, here. There they are. How's them? Do the best you can on this assignment. We'll continue tomorrow.
That's the only
And I didn't realize it was Blizzard this morning. I thought I flipped out
Hey,
my mom.
give me a little more credit, okay?